Okay, in the previous class, we already learned about the registers. Okay, that the step that you need to do in order to do the interrupt programmings. Okay, now we are going to look at how to write how to programs. Okay, the external hardware interrupts. Okay, for the okay, so this is an example for the external hardware interrupt. Okay, assume that the INT0 pin is connected to a switch. So you know that this INT0 is actually the interrupt. Okay, this is for the external hardware interrupt. Okay, to a switch that is a normally high. Okay, normally high means that it is active low switch. Whenever you press the switch, it will give when you output zero, input zero, write a program that toggle port C pin number 3 whenever the INT0 pin goes low. So what you're going to do here is you just draw the Atmega 32, and this is the port C pin number 3. So this port C pin number 3, the value of the port C pin number 3 will be toggled. Okay, every time you press these switches here. And this switches is this switch, okay, one switch is connect to INT0. And INT0, we know that INT0 is actually at PD pin number 2. Okay, port D pin number 2. So make sure that in your drawings, okay, make sure that port D pin number 2 is connected to active low switch. Okay, in which this switch here will give 0 whenever the switch is pressed. Okay, setiap kali kamu press switch, so dia akan bagi kosong. Okay, so this is a switch. Okay, this is the timing diagram lah for the switch. Okay, you have a switch. Okay, so this is switch for INT0 connected to INT0. And this switch is a normally high switch. Okay, so this produce logic 1. Okay, so this is a logic level. Okay, and then this is a time. Okay, and whenever you press your switch, okay, bila kamu press the switch, so what happened here is when you press the switch, okay, so this is where you press the switch and it will give you logic 0. Okay, so this is a 1 and this is a logic 0. So this is where you press the switch. Okay, and when this when this switch is pressed, what happened here is the interrupt will be triggered. Why? Because one CPU sends a logic 0 and it will automatically trigger the interrupt. So INT0 will be triggered after you press this SW button. Okay, this switch button. Okay, so now we're going to do the programmings. Okay, on the programming parts, okay, there are what we call here 4 steps that you need to do. 5 steps. Okay, first you need to, okay, according to what we did earlier, mana ada tak kita bagi? Okay. Okay, so 5 is actually this one. This is 1, 2, 3, 4, and 5. Okay, so basically we have a 4 lah, total of 4. Di mana step number 3 you need to have 2 places to enable the interrupt registers. Okay, so step number 1, okay, what you need to do is you need to include the avr/interrupt.h. So this is the things lah. Okay, so this is a step number 1. Okay, so include avr/io.h. This is the basic thing lah yang kita kena buat. And then include avr/interrupt.h. So this is the file of the interrupt that you need to include. Then after that, we'll start with the main program. So under the main program, okay, before we enable the interrupt register, what you need to do here is you need to enable the GPIO. okay, initialize your GPIO. Okay, since in this examples here, we have two GPIOs that we're going to use, which is a port C. Okay, port C to produce these signals here, and port D is connected to a switch. So port C, you initialize it as an input output port, while PD2 initialize as a input port. So this is what you're going to do lah. DDRC and shift one to the bit to the left by 3 bits, means that you put one to the bit number 3 inside of the DRC. So what happened after you did this? Port C now become an output port, and then next initialize PD2 supaya PD2 become input ports. So how to do that? You can simply write DDRD equal to DDRD, okay, and then do the masking, and with okay, shift one to the left 2 times. Okay, means that now you put bit number 2 dengan nombor 1, and now after that you invert it, so it becomes 0. After you get the value, then you end with DDRD. So only this bit here will have 0. The rest of the bit will have 1. Ataupun if you don't want to if you don't want to use this coding here, so you can simply write DDRD sama dengan 0B 1111 and 1011. Okay, so make sure that bit 2, this is your PD2, is set as a input port. Okay, next, once you done that, okay, before we proceed with the enable the interrupt register, what we're going to do here is, okay, satu lagi we need to because this is a connected to switch, betul tak? Earlier I already told you in the previous class, okay, every time you make this port here as a output port, okay, input port, you need to enable the pull up resistor. Okay, so how to enable the pull up resistor? You can simply write down port B sama dengan 0B0000 and 0100. Okay, so this one here, PD2, you enable the pull up resistor. Okay, this will help lah, because why? Because your what I call here, your pin D is normally high. Okay, so it will give the pin D here, pin number 2 value 1. Okay, so this is what happened here. And then this is step number 2. Step number 3, okay, in which you need to enable the interrupt register. Okay, there are 2 locations that you need to enable your interrupt. Okay, nombor 1 ialah dekat interrupt registers. Okay, either you're going to enable it at TIMSK, this is for the timer lah, or you're going to enable it at GICR. So this is for the hardware external interrupt. Okay, now we're going to focus on this part here. All right, so GICR, so you need to recall balik semula lah. This is your GICR. Okay, it is an 8-bit. Okay, and then now, okay, we only going to focus on these 3 bits here. Kat sini je kita nak tengok, which is this is INT1, this is INT0, and this is INT2. Okay, now what you're going to do? Okay, so bila kamu dah identify what interrupt that you're going to do, since this one here we're going to use the INT0. So what happened here is the cut INT0 location, which is in this location here, you need to enable it. Okay, enable at this location by putting 1. What about the INT2 and INT3? Sorry, INT1. So INT2 and INT1, you simply give 0. Okay, so means that this interrupt is disabled, only INT0 is enabled. So this is the value that you going to use. Okay. GICR sama dengan shift 1 to the location pointed by INT0. Ataupun if you don't want to use something like this, you can simply write GICR sama dengan 0B. Always use a 0B. For the binary number 01000000. So this is your INT0. Okay, and then after that, after you enable at interrupt register, then the second one here you need to enable inside of your status register. Your I flag inside of your status register. So how to enable it? By by using this what we call here syntax, which is SEI. So using this syntax here SEI, now you enable the interrupt globally. Okay, next, what you're going to do? Step number 4 is you need to write down your ISR. So belum kita tulis ISR, just put lah this one here, while one. Means that you're going to do it continuously. Is it any main program here while waiting for this what we call here this switch to be pressed? Tak ada. If tak ada, you just simply left it blank. If there are another program need to do while waiting this switch to be pressed, then you need to put the program lah untuk that main program. Now we will look at this step number 4. So this is where you need to put your ISR lah, create your interrupt service routine, and make sure that how to create it by using the ISR. And then you have a kurungan here, brackets, and make sure that the name inside of this bracket is correct. You need to refer to vector table. Refer the name of your interrupt by looking at this vector table yang kat sini. Now we are going to use use the INT0. So this is the name lah, INT0 underscore vet. So that's why here you can see ISR INT0 underscore vet. And then inside here, so this is the things lah that we need to write whenever the interrupt is triggered. So according to this question here, the INT0 will trigger when INT0 is triggered. What happened here is port C pin number 3 akan toggles. Means that it will give the first trigger dia akan bagi input 1, then kosong, which is it's for toggle bila trigger lagi, and then another trigger will give you 1, and when you trigger again the INT0, it will give you 0, and it will keep repeating. So to do that, we just simply write port C sama dengan port C. This symbol here, which is exclusive OR symbol, and you need to exclusive OR with this value. Ataupun kalau kamu tak nak guna this value, you can simply write something like this. Port C sama dengan port C. Do the exclusive OR with 0B 0000 and then 1000. Let's kita buat dulu. Let's our port C sama dengan kosong. The initial value of port C sama dengan kosong. So what happened here? Bila port C, this is your port C. The initial value of port C is a 0. So 0000000, and then you do the exclusive OR with this value here. So what happened here is, from the truth table here, A, B, F, when kosong, it will produce 0 lah. 1, it produce 0. 0, 1, produce 1. 1, 0, it produce 1. So this is the exclusive or truth table. By looking at here, these inputs here, so you can simply give the output. Okay, so this is a kosong 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 0 1 produce 1 0 0 0. So this is the output. Okay, initially, okay, the PC3 initial value is 0. Now it become 1, while the rest, okay, masih lagi tak berubah. So that's why we do this what we call here masking kat sini. Okay, kita buat masking. Okay, to make sure that only this bit change PC3 je yang berubah, while the rest of the bits remain. Okay, and then the next cycle, when you trigger again the interrupt, so what happen here is, okay, you do the exclusive OR with the same value. So what happen, dia akan jadi kosong, kosong, kosong. Satu, exclusive OR with satu, you will get 0, 0, 0, 0, 0. So now, you see here, it keep toggle from 0, become 1, 1 become 0, and then after that, it will goes back to logic 1. Okay, so this is the program lah that you need to write. Okay, now the question here is, what happened by the time micro P finish ISR, okay, which is after the micro P has do the toggling process, okay, and the INT0 still low. Okay, maksudnya you still press these switches here. You not release the switch. Okay, you still press the switch, and by that time, the micro P, by that time this toggling has been finished. The ISR has been finished. Okay, for example, I give this way here. Okay, nak senang lihat. Okay, so this toggling, okay, will occurs every 5 millisecond. Okay, so setiap 5 millisecond dia akan keep toggling. Okay, so we call lah the delay of, kita panggil delay 5 millisecond down here. Okay, to generate this toggling 5 milliseconds. Okay, so this is a kosong. This is a 5, 10, 15, 20, 25, 30. So this is the time lah in milliseconds. Okay, we started at when time 0. Okay, the value of the switch is still 1, means that you not press the switch yet. And when time is 5 milliseconds, okay, the value is still 1, means you not press the switch again yet. And when time is 10 milliseconds, now you press the switch. So what happens when you press the switch? When the CPU, okay, sense this one here, the INT0 now become low level. So what happened here is, okay, sebelum tu kita buat ni lah. So this is your output lah. This is your PC3. Okay, we started with 0 Okay, we start with 0. Initial value is 0. Alright, so when 10 milliseconds, so what happened here? Now it become 1. And this here will keep 1 until 15 milliseconds. But okay, supposedly by 50 milliseconds, yeah, this is a 5 millisecond. After it generate a 5 millisecond toggling signal, you see here at this time here, the logic level, okay, kat bawah ni, okay, the logic level of this switch INT0 still kosong. So what happens when this one is kosong? So the CPU thinks that, okay, there is another what we call here interrupt being triggered kat sini. Okay, why? Even though you only press it once, but the CPU the CPU thinks that, okay, you already trigger another interrupt. Why? Because at this moment here, the logic level kat sini masih lagi kosong. So what happened to your PC3? PC3 now become 0. Alright. So when this happened here, okay, at this time, when 20 milliseconds, what happened here is okay, the logic level here is still 0. You still press the switches, not release the switch yet. So what happen? PC3 akan jadi logic 1. Okay, let's this one here. Then here, now you release the switch. Okay, you release. When you release, okay, it will produce logic 1. Okay, after you release the switch, okay, this until 25 milliseconds. When you release the switch or CPU, the processor, okay, now find out that the INT0 now become logic high. So no more PC3 produce here. So the PC3 will stop here anyway. Okay, so this is what happens. Okay, so means that this is what happened. Okay, by the time the microphone finish the ISR, okay, which is exit the ISR and INT0 still low, means that even though you press the switch one time, okay, the interrupt keep triggering until, okay, you release the switch. Okay, we don't want to do that. Okay, we want when you press the switch one time, then the interrupt will trigger only once. Okay, we don't want the interrupt triggers several times. So how to overcome this issue from being happen? Okay, macam mana kita nak atasi masalah ni? Okay, so to overcome this, okay, we can use the edge versus level trigger. Okay, you can the interrupt can be triggered either by using a level trigger or edge trigger. So there are two types of activation for the external hardware interrupt. One is a level triggered for INT0 and INT1, and edge triggered INT0, INT1, and INT2. So in order to avoid this issue happens, okay, means that if you press the switch one time, the trigger will happens once. So we can use the edge trigger compare. Okay, don't use the level trigger, because the level trigger, okay, what happens is the interrupt will be generates, okay, every time it sends the lower trigger. But if you use the left edge trigger, so what happens here is the interrupt will be generated, okay, the interrupt will be generated whenever it sends the falling edge or rising edge. Okay, so for the IN, so this is the bits that you need to do. Okay, so for the MCU CSR register, okay, this is indicate whether the INT2 is active in the falling edge or rising edge. So this is only for the INT2 lah. INT2 will using the MCU CSR, while INT1 and INT0 will use the MCU CR registers. Okay, so for MCU CSR, okay, we're going to focus on this bit only, bit number 6, di mana if you put 0, so this is a falling edge. Okay, so what happened here is every time the falling edge of the INT2 will generate an interrupt request, and if you put 1, every time, okay, the rising edge, the INT2 generate an interrupt request. While for the INT0 and INT1, okay, we're going to look at this MCU CR register. Okay, in which if you put the MCU CR sama dengan 00 means that it is a level triggered. Okay, which is what this is the same thing happened earlier lah. Okay, which is we put, okay, every time the CPU sends the logic level 0, dia akan trigger the interrupt. So the low level of INT0 will generate an interrupt request. Okay, so this is the bits that you need to focus, do the settings. Okay, and this is for INT0, and this 2 bit is for INT1. Okay, if you put 00, so what happened here is the interrupt will trigger every logic level 0. Okay, if you put 01, okay, either any logical change, which is either falling edge or rising edge, will trigger the interrupt. If you put 10, only falling edge will trigger the interrupt. If you put 11, then the rising edge will trigger the interrupt. So this is what happened lah. Okay. So this is your switches. Okay, so this is your INT kosong punya switch. And this is without what we call here. Right, so this is without MCUCR setting, which is you put your MCUCR equal to 0. So when this one here, at this time, when it sends a logic kosong, okay, so what happened here, the interrupt will keep, sorry, not like this. Okay, interrupt akan keep repeating. Okay, until it the level it now become 1. Okay, this is without the MCUCR settings, which is you put MCUCR equal to kosong kosong. By default, your MCUCR value is kosong lah. Okay, and then if you use a falling edge trigger, so what happened to your output here is, okay, this is your interrupt. So the interrupt will be triggered. Okay, we started with kosong, and whenever it sends this what we call here falling edge, and then it will trigger the interrupts. Okay, so this is what happens. Okay, and when you choose the rising edge, which is when you put the 1 1 at your MCUCR, so what happened here is you push 1 1, which is rising edge. So every rising edge, okay, the interrupt will be triggered. So this is when you press the switch, and this is where you release the switch. Okay, so for the falling edge, when you press, it will trigger the interrupt. But for the rising edge, when you release the switch, then the interrupt will be triggered. Okay, if the logic level here, okay, while you still press your switch and the ISR is finished, then it will trigger the interrupt again over and over. Okay, so now we need to tambah satu lagi lah dekat sini. Okay, in between this step here, step number 3 here, you need to tambah another one here kat sini, which is enable, okay, interrupt triggered, which is either you choosing a falling edge ataupun rising edge. Okay, for example, let's you choose this one here, 01, which is any logical level. So what happen here, when any logical level, okay, apa yang berlaku is, okay, mula-mula dia akan, your interrupt will, sorry, okay, your interrupt will be triggered here, and when you release, the interrupt will trigger again. So this is when you choose the any logical level. Okay, so let's look at this example here. Okay, show the instruction A, make INT 0 falling edge triggered, B, make INT 1 triggered on any change, and C, make INT 2 rising edge triggered. Okay, for A, INT 0 falling edge. For INT A falling edge, so you need to do a setting inside of your MCU CR. And what value that you're going to put here? Okay, the first 4 bits here you put 0 lah, because with this bit here is not using. Okay, this is not used, so we just simply put a 0. And for the INT 0, we're going to focus on this bit only, bit 0 and bit 1. Okay, and the falling edge should be, okay, the value that you need to put here is 1, 0 for falling edge. So the value is 0B0000000 1 0. So this is int0 falling edge. Okay. B, make int1 trigger on any change. Okay, so for int1, where you're going to do the setting, the MCUCR as well. Okay, put the value, the first 4 bit here will 0. And then next int1. int1, you need to look at this bit only lah, bit 2 and bit 3. Any change, what is the value for any change? 0, 1. Okay, so you put a 0, 1, and this bit here is 0, 0. So this is int1, and then any changes. Okay, so int1 kita do a setting at this bit, int0 do setting at this bit. Okay, what about the int2? Okay, for the int2, okay, there is another register we call it as a MCUCSR 0B. Okay, and what bit that you need to look at? Bit number 6. Okay, MCUCR only. Okay, for this, for only int2, okay, we're going to do a setting at this bit only. Okay, bit number 6. Di mana for the falling edge, put 0, rising edge, put 1. Okay, since this is a falling rising edge, so you put 1. So 0, 1, 0, 0, 0, 0, 0. So this is int2 rising edge. This is how you're going to do the settings for the interrupt triggered. Either it's a level triggered or edge triggered. Any question up until here? Ada soalan tak sampai sini? Okay, kalau tak ada soalan, next we are going to look at, okay, this is the same example as above. Yang ni kita pakai example yang sama. Okay, now we are going to make sure that, okay, the int0 will be triggered. Okay, okay, we're going to make sure that whenever int0 goes low, it toggle port C only once. Okay, sekali saja, not several times as the previous example. So how you going to do that? Okay, we just simply put this MCUCR equal to, okay, you can choose either to use a rising edge or falling edge. Okay, for the rising edge, okay, you can simply put the 0B 0, 0, 0, 0, 0, 0, 1, 0, or MCUCR 0B 0, 0, 0, 0, 0, 0, 0. So this is a rising edge and this is falling edge. Okay, so you just put this instruction only, this syntax. Then after that, your program earlier, okay, the interrupt will happen once every time you press your switch. Okay, so we already finished the external hardware interrupt. Any question up until here? Ada soalan tak for the external hardware interrupt? All right, if no questions, if you have a questions, well, don't be shy. Okay, please ask me. Either you can write in the chat box or simply turn on your microphone. Okay, now we are going to look at the timer interrupt programming. Okay, so this is the interrupt will occur every time. Okay, the time interval is what we call here is reached. Okay, setiap kali you set your interrupt to trigger every, contoh lah, you set your interrupt to be triggered every 20 seconds. Then every 20 seconds, the interrupt will triggered. Okay, when the timer reach the 20 seconds delay. Okay, so basically in Atmega 32, there are three timers. Okay, we already learned about this timer previously. Okay, so timer 0, timer 1, timer 2. Just for the recap, timer 0 is 8-bit. Okay, timer 1 is 16-bit and timer 2 is 8-bit. Okay, and each of these timer now have two methods. Either you're going to use a overflow ataupun sama ada we call it as a normal mode, or compare mesh timer flag, which is a CTC mode. Okay, you have two modes for the timer programming. Either you're going to use a normal mode or CTC mode. Okay, and then so let's look at the rollover timer flag, which is by using the overflow. Okay, so if the timer interrupt in the interrupt register is enabled, in which you need to enable inside of the TIMSK. Okay, the timer overflow flag TVOX is raised whenever the times roll over and the micro P jumps to the interrupt vector to service the ISR. Okay, means that every time your TOV flag, either TOV 0, 1, or 2, equal to 1, so what happens here is the CPU know that you're going to request the interrupt. Okay, so this is where you're going to do the IRQ. IRQ kita panggil sebagai interrupt request. Okay, once you request the interrupt, then what happens here is the CPU need to do this ISR, interrupt service routine. Okay, to enable the interrupt for a given timer, okay, we must set the TOIEX bit that held by the TIMSK register. Okay, so you need to, inside of the TIMSK register, you need to enable which timer interrupt that you're going to use, either timer 0, overflow method, or CTC mode, ataupun you're going to use a timer 1, overflow method or CTC mode, and timer 2, overflow method and CTC mode. Okay, so to enable the timer interrupt, okay, contoh, let's say timer 0, we should write as follow. Okay, contoh you're going to enable timer 0 overflow. Okay, so by looking at this TIMSK, so this is a TIMSK. Timer 0 overflow is dekat bit kosong, which is T0 TOIE0. So this is a timer 0 overflow. So you need to enable at this bit. Okay, how to enable? Sama juga dengan GICR, which is you just simply write TIMSK. Sama dengan 0B and put 1 to the timer that you're going to enable the interrupt. So this is a timer 0 overflow method or normal method. Okay, if you're going to use the if you're going to use a timer 0 but CTC mode, okay, you can simply write TIMSK sama dengan 0B00000010, which is at this bit here. 0C, okay, IE0, which is a timer 0 output compare mesh interrupt enable. Okay, put 1 to this bit, then automatically, okay, you enable the interrupt for the timer 0 using the compare mesh. Okay, and just to remind you, you cannot enable both timer 0 using either normal mode or CTC mode. You cannot do that. Okay, only choose one. Right. Okay, so now we are going to look at another examples. Okay, write a program, okay, to enable the timer 0 overflow interrupt. Okay, kita dah tulis tadi. Okay, timer 0 overflow interrupt, which is at bit 0. So just simply write TIMSK sama dengan 0B000000. Okay, if you don't want to write something like this, okay, which is quite longer, okay, you can simply write TIMSK, which is a shorthand. Okay, shift 1 to the location of TOIE 0 pun boleh. Okay, which is quite similar actually. Okay, B. Okay, and make sure lah, after you enable the interrupt at this timer interrupt register, then followed by SEI lah. Make sure D is the second things lah that you need to enable. Okay, the first thing is at your timer interrupt. The second one here at your status register at your I bits. Okay, B. Disable the timer zero overflow interrupt. Okay, kita nak disable pula. How to disable? Okay, to disable simply write TIMSK sama dengan kosong. Okay, means that the whole interrupt you disable it. Okay, and C, show how to disable mask all the interrupt with a single instruction. Okay, macam mana nak disable all interrupt with a single instruction? Okay, to disable all interrupt with single instruction, we can disable it inside of this status register, which is dekat you punya I flag. How to do that? By simply write down CLI. Okay, means that clear I flags inside of the status register. So automatically all interrupt, even though you already enable the interrupt inside the TMSK, inside the DSR, when you put CLI here, means that all interrupt are disabled globally. Okay, means you cannot trigger the interrupt anymore. Okay, and let's look at these examples here. Okay, so this program use timer 0 to generate a square wave on pin port B5, while at the same time data is being transferred from port C to port D. Okay, so you have a port B pin number 5. So this is where you're going to generate a square wave. Okay, this square wave here will be generated by using a timer interrupt. Okay, meanwhile, okay, you have a port D and port C, which is this port C will display, this port D, okay, this LED from port D will display whatever you key in, okay, whatever you send from your port C. So this is actually your main program, okay. So now we already identified, okay, which process is belong to the timer, to the interrupt ISR, which process is belong to the main program. Okay, so what you need to do, okay, similar what we did in the external hardware hardware interrupt, which is the first one here. Okay, what you need to do is you need to include the interrupt header file. So include first avr/io.h, this is standard lah, and then include avr/interrupt.h. Okay, so after you include these files here, so next what you're going to do, okay, we start with the main program lah, int main void. Okay, and on the int main void, okay, so the second step, initialize your GPIO. Okay, we need to initialize your GPIO. Okay, since now we can see here port C, okay, is connected to the switches, while port D connect to LEDs, and port B is the output to generate square wave. So simply write DDRD sama dengan OXFS, meant for D as our output port. DDRC sama dengan 0, make the whole port C as an input. Why? Because you're going to connect them to the switches and enable the pull-up resistor. Okay, 0XFF. Yes, and next, port B, pin number 5. Okay, you're going to make it as a output port as well, because this is to generate the square wave. So DDRB sama dengan 0B. Okay, you can make the whole port B as a output pun boleh. If you don't want, okay, just simply make the port B pin number 5 as a output. Okay, so 0, 0, 1, 0, 0, 0, 0. So PB5 jadi outputs. Right. So anything? Okay, after you finish here, next, what you're going to do? Okay, now we need to enable. This is a step number 3, which is enable the interrupt register. Dekat mana nak enable interrupt just register? Inside of TIMSK. Okay, what timer that we're going to use? Timer 0. Okay, and for the timer 0, what is what we call here mode that we're going to use? Okay, let's say in this example, we are going to use a normal mode. Okay, so 0B 0, 0, 0, 0, 0, 0, 0, 1. Timer 0 normal mode. Okay, so you enable a timer 0 normal mode interrupt, and then after that SEEE. Okay, enable the second one here. Okay, which is at the location of your status register. Okay, lepas tu nak buat apa pula? Okay, now we going to do the timer settings lah. Okay, so do a timer settings. Okay, since this is a normal mode, so you need to find out what is your TCNT 0. Okay, so this is your TCNT 0. So what value that you're going to put to your TCNT 0, depending on the interrupt that the delay that you're going to generate lah, and the extent of your clocks, the speed of your extent. All right. So in this case here, okay, we using the negative 32. Okay, so negative 32. Actually, if you negative 32, if you change it to the what we call hexadecimal, it will give you the value here. Dia akan bagi you value. So you just put that value, put it to your TCNT. And then what about the TCCR0? Ingat lagi tak? Timer settings. Okay, so this is the first step for the timer programming, which is load the TCNT, do the timer setting. Okay, after you do the timer setting, then after that the timer will be started. Okay, the timer akan start. Okay, so here TCCRO. So what value that you're going to put here? Okay, kena recall balik lah. Okay, so this is your TCCR. Okay, bit 6 dan bit 3 for the settings. Okay, which is normal mode 00. You need to put here. What about the prescale? Since there is no prescale in this example here, so we just use no prescale. So that's why the value here you can see here 0, 1. So 0B 0, 0, 0, 0, 0, 0, 0, 1, which is a timer 0. Yang ni interrupt this is interrupt. Okay, timer 0, normal mode, again normal mode, and no prescale. Okay, and next, while 1. Okay, so this is where your while loops here. Okay, we'll keep repeating. Okay, under the while loop, this is your main program. Under the while loop, what program that you need to write? Okay, you need to write this program lah, in which whatever value that you read from the port C will be displayed on your port D. Okay, so port D sama dengan pin C. Okay, why pin C? Because this is the value from the switches will go to your pin C, and from this pin C you send out to your port D. Okay, so this is your main program. Okay, you already finished the main program. Okay, so these two settings here for the timer programming must be set on your main program. Jangan letak pada kamu punya ISR. If you put inside of your ISR will never occur. Okay, because your timer not started. Okay, so that's why we need to put inside of this timer on this main program. Okay, compared to previously, kita call that subroutine. Okay, so that we sebab tu kita letak dalam timer subroutine. But now we not call that subroutine. Okay, it will automatically request by the TOV0 flags. Okay, so that's why you need to initialize your timer setting at this part here. So this is a part nombor tadi. This is nombor 1. This is nombor 2, 3, and this is a part step number 4. Okay, load the TCNT value, and step number 5 is set your TCCR settings and then while loop. Step number 6 barulah, okay, start with your ISR. Okay, so ISR. Okay, make sure that this ISR name is correct lah. Okay, how to know that the ISR name is correct or not? Okay, by refer to the vector table. Okay, since we are using a timer 0 overflow method, so the name is timer 0 underscore OVF for overflow under VEC vector. Okay, so inside of this timer here, okay, no need to monitor the TOV flags. Kenapa? This TOV flags will be monitored by the what we call here, by the interrupt. Okay, interrupt will monitor here, this one here. Okay, because we already set this one here, so this interrupt here will monitor the TOV0 flags. Okay, and step number 6, 7. Okay, stop your timer. Okay, tak perlu stop pun tak apa, sebab dia automatically stop after that. Okay, and then you need to set again lah this settings here. Okay, so TCNT0, load again the value. And TCCR0, okay, put back the settings. Okay, to start it over again. And then, because we're going to do the toggle, so make sure that this toggling is inside here as well. Okay, so the port B sama dengan port B equal to bit number 5. Okay, which is we're going to do this here. Okay, nak hasilkan this square wave here. So you need to do it to toggle this output. Okay, from 1 become 0 and then become 1. All right, that is for the timer program by using overflow methods. Any question up until here? Ada soalan tak? Okay, if no question, then we're going to look at the next slides. Okay, so programming timer interrupt using the compare mesh timer flag, which is using the by using the CTC mode. Okay, so sometimes a task should be done periodically. Okay, so the program can be written using the CTC mode and by using the compare mesh flag. Okay, so to do so, load the OCR register with the proper value, and initialize the number to the CTC mode. Okay, when the content of TCNT match with the OCR, the OCF flag is set, which causes the compare interrupt to occurs. Okay, so similar to what we did in timer programming. Okay, so this CTC will done periodically. Okay, which is it will keep continuous generate the delay. But for the overflow, actually it will occurs one unless okay you start again. Okay, so this is where to do it periodically. Okay, in which we need to load again the value and start again the timer. Okay, if you not use put this one here, it only triggers once. Lepas tu dia habis, tak generate the interrupt anymore. Okay, the timer anymore. Okay, so that's why we need to put this step number 7 kat sini. Okay, which is you load again the value and set the TCCR. Okay, to make it continuously, periodically. Okay, creating the delay. Okay, let's look at these examples here. Okay, using timer 0, okay, write a program that toggle pin port B every 40 microseconds, while at the same time transferring data to port C from port C to port D. Assume that the extent is 1 megahertz. Okay, so now we are going to do the toggling. Okay, sama macam tadi, you have this one here, PB5. Okay, we'll do produce a square wave. Okay, this square wave is 40 microseconds. Okay, and then you have a switches from port C. Okay, whatever value from these switches will be displayed on this LEDs. Okay, so this is a port D. Okay, now okay, it already gives the delay already there, extra already there. Now what we're going to do is we need to calculate what is the value that we need to put inside of the OCR. Okay, by using the formula that we learned earlier lah. Okay, which is T sama dengan 1 over F. Do we have to use a prescale? Okay, in this case here, no prescale. So T sama dengan 1 megahertz divided with, okay, 1 over 1 megahertz. So you will get 1 microsecond. And delay equal to T multiplied with count. Okay, you have a T, 1 microseconds. You have a delay to generate is 40 microseconds. And now you're going to find out what is your count. So count sama dengan equal to delay divided with T, you get 40 times. Okay, so this is only count. And then the third equation here that we have is TCNT, sorry. Apa yang kita punya third equation? Saya pun dah lupa. Anyone? Siapa nak tolong? Okay, OCR equal to TCNT minus count, plus count minus 1. Okay, TCNT always 0, count 40 minus 1, then the OCR value will be 39. So this is the OCR value that you need to put to your OCR kosong. Okay, so now we're going to write down the programs. Okay, ni salah ni So tolong baiki ni, this is not 40. 39. Okay, from the calculation, the OCR is 39, not 40. Okay, so first, started lah. include the avr.io.h, and then include this interrupt.h file. So this is the first thing. Okay, and then the second step is initialize your input output ports. Okay, so DDRB sama dengan 0B0010000, which is this one here. You're going to make your port B pin number 5 as an output port, while the rest of the pin become input port. DDRC equal to 0, make the whole port C as a input port, because you're going to connect these switches to your port C, while port D is connected to the LEDs. So that's why DDRD sama dengan OXFF. Okay, step number 3, enable the interrupt. Okay, there are two locations that you need to enable the interrupt. One on the TIMSK, and the second one inside of the status register, which is on your iFlex. Okay, so TIMSK, so this is the setting. Ingat balik semula, TIMSK to enable timer 0 CTC mode, okay, which is at bit number 1. Okay, so the value is 0B 00000010. Okay, so this is where you're going to enable the OCIE 0. Okay, timer 0 CTC mode. Enable the interrupt for timer 0. Okay, and then followed by SEEE. So this is where you need to do the step number 3. And step number 4. Okay, step number 4 need to follow the timer punya programming lah. Which is, first, TCCR0, we set dekat 0. Oh, sorry, not TCCR0, TCNT0 I'm sorry, TCNT0. Okay, this is the first step lah. Okay, TCNT0. Okay, you load with a 0. Okay, because here TCNT always 0. And then OCR0. Okay, the calculation we get here is 39. Okay, so you just simply put 39 there. And then after that, you set your settings on your TCCR0. Okay, so look back at TCCR0 settings. Okay, so this is your TCCR. Okay, bit 6 and bit 3. Okay, the value that you need to put here for the CTC mode is 01 lah kat sini. Okay, any prescale used in this examples here, no prescale. Okay, so for the no prescale, is the value is 001. So this is the value 000. Okay, 0B0000101. So timer 0. CTC no prescale. Okay, which is similar to this one. Okay, TCCR0 sama dengan 0x09. Okay, so please make ni tolong baiki ni, this is a 39. Okay, not what we call here 40. 40 salah Okay, then after that, after you finish the step number 4, then followed by your main program lah. Okay, while one, do it forever. And what happened to your main program? Okay, you're going to send whatever value from the port C to the port D. So that's why under this while loop here, port D sama dengan pin C. Okay, and the good part here is this is a step number 4, 5 ya. Is it step number 5? 4, 5, 6. Okay, we call it step number 7 lah. Okay, step number 7. Okay, you see here. Do the ISR for timer 0 CTC mode. So this is a ISR timer 0 underscore com underscore vet. This is for the timer 0 CTC mode. And then you see here, no more setting inside here. Only do the toggling for the PB5. Okay, tak perlu buat macam yang ni. Previously, Kalau kamu tengok yang ni tadi, you see you need to load again the TCNT0. Kalau kamu guna overflow, start balik semula kamu punya TCCR settings. But now, since this CTC mode will be done periodically, so what happen here is you just put this toggle saja. So it will automatically done for your CTC mode. Okay, the delay will keep generate continuously. Okay, that is for the timer interrupt timer using the CTC mode. Any questions? Ada soalan tak up until here?
No question, Doctor.
Okay, no questions. So I assume that all of you already understood. Okay, regarding the timer. So we already finished the timer interrupt, external hardware interrupt. Now we are going to look at the interrupt parity and interrupt inside interrupt. Boleh tak happens? Okay, interrupt inside interrupt means that if you have one interrupt execute and then the other interrupt going to intersect, is the second interrupt going to happen? Okay, we're going to see in the next few slides. Okay, so first let's look at the interrupt priority. Okay, what will happen when two interrupts are activated at same time? Okay, means that okay you have a IRQ. Okay, so this is INT0. Saya tak nak guna IRQ lah. And this is INT1. Okay, so this is the signal. And both interrupt here triggered at the same time. Okay, what happened? Which interrupt will go first? Is it INT0 or INT1? Or if you have another interrupt, timer interrupt, overflow method. Okay, so triggered at the same time. Okay, yang ni kita rujuk kepada timer interrupt overflow, we rujuk kepada dia punya TOV flags. So TOV flags. Okay. So you have three interrupt triggered at the same time. So which interrupt will go first? Interrupt mana yang CPU akan execute? Is it INT0, INT1 or timer 0 overflow method? Okay, so the answer will be interrupt priority. Means that the CPU will execute based on the priority level, which interrupt have the highest priority will be executed. Okay, the one with the higher priority will be executed by CPU. Okay, so if two or more interrupt are activated at the same time, the interrupt with the higher priority is served first. Okay, the priority of the interrupt is related to the address of the interrupt in the vector table. So we need to look back in the vector table. Okay, tengok balik semula vector table yang mana have the highest priority, which interrupt have the lower priority. Okay, so according to this is a interrupt vector name. Okay, we just look at the vector table. Mana kita punya vector table? Okay, see, this is a interrupt vector table. Okay, so as I mentioned earlier, okay, the interrupt with a lower addresses have higher priority compared to the interrupt with these large addresses. Okay, means that okay, the highest one is a reset, followed by INT0, INT1, INT2, then after that followed by this timer. So since just now we have INT0, INT1, and count timer 0 overflow, which is this is the addresses. Okay, so all this interrupt is triggered at the same time. So the answer is INT0 will be executed while INT1 and timer 0 overflow is not executed by CPU. Why? Because the INT0 has the highest priority. Okay, that is the answers. Okay, next. Mana tadi? Okay. So now we're going to look at interrupt inside interrupt. Can interrupt be triggered inside another interrupt? Okay. So what happened if the AVR is currently executing an ISR belong to an interrupt and another interrupt is activated? What will happen? Okay, the answer will be when AVR begin to execute a certain ISR, another interrupt cannot be invoked or being triggered. Okay, so interrupt inside interrupt will never be happens. Okay, means that when an AVR begin to execute an ISR, what happened here is it automatically disable the I bit in status register. So what happened when the I bit in status register is being disabled? So means that you already disable the interrupt globally. Okay, the condition to interrupt to make to add the condition for the interrupt to happen is first the register interrupt must be enabled and the status register, which is the I flag inside the status register, must be enabled as well. But since bila the ISR is execute, the I bit dalam status register is disabled. So the second the second condition is not met, means that the interrupt will not trigger. Okay, causing all the interrupt to be disabled, thus no other interrupt occurs while serving the interrupt. So interrupt inside interrupt cannot happen for the AVR. Okay, this is only for the AVR microprocessor. Okay, if you have another processor, okay, that is another story because another processor might have interrupt inside interrupt depending on the priority level. Okay, so when the RETI is executed, means that the ISR is finished. Okay, the AVR will automatically enable the I bit inside the status register. Now, when the ISR finished, AVR automatically enable the I bit, causing the other interrupt to be served. Okay, means that if the interrupt still triggered after the ISR has finished, then that interrupt will be served by the CPU. Okay, so that is for today. We already finished the interrupt punya module. Any question up until here? So next week we started with the ADC lah. Ya, minggu depan kita akan masuk A. So let's look at this example. Boleh nampak Kamu ada tak soalan ni? Tak ada dalam kamu slide?
Tak ada soalan.
Okay, kamu boleh screenshot this soalan and we read it together. Okay, you are asked to design. Boleh nampak tulisan ni? Ke tak berapa nampak?
Boleh.
Boleh sebab ni saya pakai yang second monitor saya ni punya resolution is low. Okay, compared to my main screen. Okay, if you can read, okay lah, no problem. Okay, so you are asked to design a decoration lighting system with 8 LEDs for a client. Okay, the system will be placed on the front desk of the client shop to attract customers to their shops. Okay, the placement of the LED is in a row. The client also requests to have two different set of sequential which have been defined in table here. Okay, you have two patterns here. Pattern 1, okay, this is the LEDs. Okay, this is the LED will be blinking lah. Means that when the pattern 1 is triggers, what happen here is for the first sequence, all LED will lights up. Okay, after 100 milliseconds, then it will turn off. Okay, it will all the this is where you going. This is for the pattern one. It will do the blinking. Okay, LEDs blinking. All the LEDs will be blinking. Okay, for the pattern two. Okay, so this is the sequence of the LED. Okay, first two LED from bit LED 0 and LED 1 will turn on. After 100 millisecond, this LED here will turn on while the rest of the LED turn off. 100 millisecond, LED 4 and 5 will turn on, and another 100 millisecond, LEDs 6 and 7 will turn on. Okay, so the system use a microcontroller AVR Atmega 32 with 8 LEDs as an output connected to port C. Okay, so kita lukis dahulu. We have Atmega 32, port C, and port C is connected to LEDs. Okay, use timer 0 to generate the 100 millisecond delay. Okay, timer 0 nak generate 100 millisecond delay. Two external interrupt INT0 and INT1 will be used. Okay, so you have INT0 and INT1 to generate this pattern here. Okay, so triggering INT0 will generate one pass of pattern 1. Okay, so this is generated by INT0, and then INT1 will generate one pass of pattern 2. Okay, the CPU frequency is 1 megahertz. Okay, now you have INT0, INT2, and port C. Okay, so the question here is, okay, since this is an external hardware interrupt, okay, where we going to put the switch of pattern 1 and pattern 2. Okay, that is the main question. Okay, the first question that need to be answered. Okay, INT0, nak sambung kat mana ni INT0 ni? Siapa tahu? INT0. Kat mana kita nak letak switch INT0? Okay, means that every time you press the switch, the pattern 1 will be triggered. And when you press the INT1, the pattern 2 will be triggered. Where are we going to put this INT0? Anyone? Ingat lagi tak? Okay, INT0, okay, you need to sambung pada PD2. And INT1 sambung pada PD3. So you have this is PD2 and PD3. So PD2 will trigger INT1. It is it is INT0. Okay, if you're not sure where is the location of INT0 and INT1, okay, you can refer to attachment. Okay, that will be provided in the final exam or your test, and you need to look at this gambar here. Okay, the Atmega 32 pin out. Okay, so now you see here INT0 dekat mana, PD2, INT1, PD3. Okay, so after you finish done that, okay, identify the location of your switches. Then after that, what we going to do? Okay, we need to calculate dahulu lah sebab kita ada timer 0 ni. Okay, to generate 100 millisecond delay. Okay, so we need to do the calculation. Okay, of this delay calculation. Okay, macam mana nak buat calculation? Okay, since this question here doesn't tell us what is what we call here, which method that we're going to use. Okay, just you can select either you're going to use a CTC mode or you can use the normal mode. Okay, let's use the normal mode. Okay, so timer 0 delays that you're going to generate is 100 millisecond. Boleh ke 100 millisecond 1 megahertz? Okay, let's check whether can or cannot. Okay, first thing first. Okay, what you're going to do here is mula-mula kita nak kena dapatkan kita punya we are going to look at the largest delay that can achieve from timer 0. Okay, what will be the largest delay can achieve from the timer 0? How to get the largest delay for the timer 0? Siapa nak tolong? How to get the largest delay for timer 0? What you need to do? Okay, you need to make sure that your water bottle is empty lah. Okay, because we use the overflow method. Okay, make sure that the TCNT value is empty. Okay, we should you put it with a 0. Okay, when TCNT sama kosong, okay, from the calculation here is TCNT sama dengan 255 minus count plus 1. Okay, so you will get your count. Okay, TCNT sama dengan kosong, so we will get count sama dengan 256. Okay, so now we are going to find out. Okay, so this is the largest delay lah that you can generate. Okay, by the since it is 8-bit timers, so 256 lah. Alright, so now we're going to find out. Okay, what is the optimum prescale that you need to use in order to generate a 100 millisecond delay? So how to do that? Okay, need to try one by one lah. Okay, which is kita tahu T sama dengan 1 over F. Okay, di mana F equal to F bahagi dengan prescale. Okay, if you put this here to this equation, so you will get 1 over F bahagi prescale. Okay, which is equivalent to 1 bahagi F over prescale. Okay, sama dengan prescale over F. Okay, so this is your T. T is actually prescale over your F. Okay, so let's, if you put, okay, and then delay sama dengan panjang ni, dia punya solution dia. Okay, so delay sama dengan T multiply with count. Betul tak? Okay, so now we have a delay. Delay yang kita nak generate is 100 milliseconds. And count we already have. Okay, the largest delay, which is 256. And now we're going to find it, what is the T. So T sama dengan, okay, so let's masukkan, okay, so this one here, sorry. Okay, so this is the delay. By using this formula, okay, prescale bahagi F darab dengan 256, then you will get the largest delay that you can generate. Okay, so this is a without a prescale 8, then we have a 64, 128 or 256 after that, and the last one is 1024. Okay, 256. Okay, can anyone press the calculator? Saya tak ada calculator. Okay, what is the delay? Okay, untuk yang ni, so F is, what is F? 1 megahertz. Okay, 1 bahagi 1 megahertz darab dengan 256. Berapa dapat kat sini delay? What is the largest delay that you can generate here?
2.56 to the power of 10.
56 power of 10 ya?
Darab 10 kuasa negatif 4. Ni versi Dina betul.
10 kuasa negatif 4.
4. Atau 256 micro second.
Okay, 256 microsecond. What about 8? 8 bahagi 1 MHz darab 256. So simply 8 darab dengan 256 microsecond. What will be the value?
2048 microsecond.
2048 microsecond, which is equivalent to 2.048 millisecond. Alright, so 64 darab dengan 256 microseconds. What you get?
Si- 16.384 millisecond.
16.384
384
millisecond. And then 256. Okay, so yang ni tak cukup. Tak cukup because we're going to generate 100 millisecond delay. What about 256? 256.
63.536 millisecond.
Okay, 6 milliseconds.
65.
65.
65.
Okay, 65. Okay, 65.536 milliseconds. So not enough. Okay, I'm sure that 1024 should be enough. Okay, what about 1024? 1024 multiply with 256 microseconds.
262.144
262.144
millisecond.
millisecond. So from here, okay, we can find out, okay, the 1024 will be the best prescale to generate 100 millisecond delay. Okay, so based on this calculation here, so we need to find out what is the TCNT value after that. Okay, so sekarang ni T, okay, so we have the delay sama dengan T multiply with count, in which, okay, count sama dengan delay. The delay that you're going to generate is 100 milliseconds, okay, divided with T, okay, di mana T is prescale 1024 divided with 1 megahertz. Okay, so how many counts that you get? Okay, 100 millisecond divided with your 1024 and divided with 1 megahertz. Berapa dapat ni? Which is 100 millisecond multiplied with 1 megahertz divided with 1024. Apa ada calculator? Okay, 97.656. Okay, 97.656. Okay, so this is the number of counts. Okay, so this one here, okay, you can use 98. Okay, so the count is 98 times. Okay, so from here, TCNT sama dengan, okay, put it inside the third equation, which is 255 minus count 98 plus 1, and then you will get 255 minus dengan 98 plus 1. Okay, so the TCNT value is 158. Okay, so this is the TCNT value. Okay, you can change it to hexadecimal if you want. Okay, if not, you can use the decimal number. All right. So when we've done this, then after that, okay, what we need to do is, okay, we need to start writing the program lah. Okay, so I just simply put it down here. Okay, mula-mula hashtag include avr/io.h. Okay, this is the first thing that you need to include. And then we have the interrupt. Okay, so include AVR interrupt dot h, and then you can define your CPU speed. Okay, which is a define f underscore CPU. Okay, 1 megahertz. Okay, so this is the important things lah. Okay, header, IO header, and interrupt header. Okay, and then after that, okay, before we start with our main program, okay, so this is main program, int main void. Okay, before that, you need to what we call here, declare. Okay, declare the 100 milliseconds. Okay, because we are going to generate a 100 millisecond delay, so just declare void and delay 100 ms. Okay, void. So just on top of this, okay, just above your main programs. Okay, if not, until later on, what happened here is when you put your delay subroutine down here, okay, the compiler will not cannot recognize your delays in your main program because you put it down here. If you put it on top of here, then every time you call the delay 100 millisecond, the compiler will know this one already been defined or initialized. Alright, so under the main program, okay, so this is the main program. So apa kita nak buat inside of the main program? Okay, mula-mula, okay, we have a few GPIO, input output port that you need to initialize lah. Okay, which is we have a DDRC. Okay, and this DDRC you need to make it as a output port. Okay, you see here, from this here, we have a port C connected to LEDs. And then we have this port D here, which is connected to the switch INT1 and INT0. Okay, so DDRD, I simply make the whole DDRD as a input port. Okay, then enable the pull-up resistor. Okay, and so this is step number 1 tadi. Step number 2. Okay, which is GI. Okay, this is step number 2. Sorry, this is step number 3. Okay, GICR. Okay, you need to enable the interrupt on your interrupt register. Since this is an external hardware interrupt, we using the INT0, INT1, so we need to enable the GICR. So the value will be 0B11 INT0, sorry, INT1, INT0, INT2, you disable it, the rest you put 0. Okay, so INT0 and INT1. After that, SEEE lah. Okay, enable your iFlex globally. Okay, interrupt globally. And before you start with step number your ISR, okay, so what you need to do here is kita kena okay, do the apa ni, interrupt trigger setting, either falling edge or rising edge. Okay, because we're going to make sure that every time you press the switch, it will trigger the interrupt once. Okay, one time. Okay, so we need to do it on the MCU CR. Okay, so 0B 0000. Okay, if you're going to choose a what we call here falling edge, okay, so the value will be 1010. So this is for the INT0 falling edge, and this is for the INT1 falling edge. Okay, if you're going to choose rising edge, So you can put the 1, 1, 1, 1. Okay, no problem. Okay, because in the question it doesn't state, okay, either rising age or falling age. Okay, you can choose both of them. Okay, and then next, okay, while loop. Okay, we already discussed all these things here. So started with the while loop. Under this main program while loop, do we have anything inside here? Ada tak? Okay, macam tak ada tadi. Okay, so just leave it kosong. Okay, just leave it something like that. And now we go to the interrupt service routing punya programming. So we have two ISR. Okay, because we have INT0, INT1. So ISR, now we started with INT0 dulu lah. INT0 underscore vet. Okay, make sure that the name is correct lah. Okay, so this is the ISR for INT0. Okay, and open curly bracket and close curly bracket. Okay, so what would be the program inside INT0? So INT0, so this is the LEDs that you need to turn on lah. Okay, this is the pattern that you need to give. Okay, whenever the INT0 is triggered, which is port C sama dengan, okay, the whole port C is turned on. So 0xFF. Okay, make sure that the LEDs ni, dia punya configuration is correct lah. Okay, if the question asks you to use the common NET, then you need to give 0, okay, to turn on. If you use a common cathode, then you need to give 1 to turn on. Okay, since this one here, okay, we choose the common cathode, so the first value here to turn on, we need to give 1 lah. So that's why the value I send here is FF, which is indicate for 0B111111. I set it to port C. After that, okay, call a delay lah, delay 100 milliseconds. Okay, and then the second sequence here, which is you need to turn off, okay, the whole LED. Just simply give a 0 to port C, then call a delay 100 milliseconds. Okay, so this is for the INT0 vector. Okay, any question up until here? Boleh follow tak? Right, so now we continue with the second interrupt service routine, which is ISR for INT1. So ISR INT1, and make sure the name is correct lah, underscore vet. Okay, and then what is the program that you need to put here? Okay, for the INT1, every time it's triggered, it will produce this pattern here. Okay, mula-mula, these two bit will turn on, followed by this bit, and the last one is the bit 7 and bit 6. Okay, so you just simply write down something like this. Port C sama dengan, okay, why not we use the binary representation? Easy for us to identify the what is the value. Okay, 0, 0, 0, 0, 0, 0, 0, sorry, not. Okay, and this one is 1, 1 ya. Okay, 1, 1. So bit 0 and bit 1 is turned on. And then after it's turned on, call a delay lah. Delay 100 milliseconds. And then this is for the sequence number 1. Okay, sequence number 2, port C sama dengan 0B00001100. So this is where your bit 3 and 4 is turned on. Call the delays. Okay, and then sequence number 3 is port C 0B0011. So now bit 4 and 5 is turned on, the rest of the bit turned off. Call the delay 100 milliseconds. And last but not least is port C sama dengan 0B11. Okay, now it's bit 6 and 7 is turned on, the rest turn off. And call the delay 100 milliseconds. Okay, so this is for the interrupt programming. Okay, we already finished the interrupt programming, but okay, now what we need to do is to do the timer punya programming. Okay, this delay 100 milliseconds subroutine. Okay, so I just put it here. Okay, so void delay 100 milliseconds. Okay, so what is the program that you need to write down here? Okay, first you need to load the TCNT0. What value that you need to load to your TCNT0? We already calculate it 158. Okay, then after that, the TCCR settings. Okay, what will be the TCCR settings? Okay, yang ni kita kena tengok lah. Okay, what is the TCCR setting? Okay, since bit here and 3, normal mode 00, and prescale that you use is 1024. Okay, for the 1024, what would be the prescale? Berapa prescale untuk 1024? 101, is it? Betul tak? 101. Can you check back? If not mistaken, 101. Betul ya? 101?
Betul.
Okay, so 0p. Okay, ataupun you can use the 0x. Kalau panjang sangat 0b, so divided by 4, this is 0. And this 1, 2, 4, 8, so 5. So the value is 0, 5. Okay, so this is a timer 0 normal mode with a prescale of 1, 0 to 4. Okay, lepas tu nak buat apa pula? After that, what we need to do? After set the TCCR, the third step, what we need to do on the third step, monitor the flags lah. Okay, how to monitor the flag by using the while loops. Okay, check the TIFR and with TOV0. Why TOV0? Because we're using the timer 0 overflow method, and check it whether it is 0. If yes, it will keep looping here. If not, then we go to step number 5. Step number 4, which is stop the timer. How to stop timer? Put 0 to your TCCR 0. And next, step number 5, we need to clear this TOV0 flag. So, TIFR, okay, 1 TOV. Yes, that's it. Okay, so this is for the delay programs. So we already answered this question. Okay, kita dah jawab soalan yang ni tadi. Okay guys, any question up until here? I think we stop here. Okay, next week we will continue with the